This video shows you how to define air handler data in CHVAC. Click the A button in the toolbar to open the air handler data window. CHVAC adds 100 blank air handlers to each new project you create. We are now editing Air Handler 1. Let's name this air handler AHU1. The system type options let us choose how the cooling air is distributed out to the rooms in this air handler. Constant volume means the same amount of air is used all the time, and there are no automatic dampers to change the volume of air being sent to the rooms. VAV stands for Variable Air Volume and means there will be VAV boxes that automatically change how much air certain rooms get throughout the day. For constant volume systems, the proportion option determines the maximum supply CFM required by all the rooms together and proportions this amount back to the individual rooms based on their peak cooling loads. So all the rooms in the air handler together receive enough air to cool the entire space, but an individual room may get less CFM than is required during its peak time. The sum of the peaks CFM method determines the maximum supply CFM required for each room at its individual peak time and sums these maximum requirements together to use for the air handler supply CFM. Since rooms usually have different peak times, the system as a whole will normally provide more air than is ever necessary for the rooms. Let's select the sum of peaks option for this air handler. The excess supply air option lets you choose what CHVAC does whenever more air is being sent to the rooms than is needed to just cool the space to the desired temperature. For reheat in reserve, CHVAC will use the entered leaving coil temperature and create a supply side load to balance things out. In the reports, the program will call that artificial load either reheat or reserve. For adjust, CHVAC will raise the temperature of the leaving cooling coil just enough so that there is no excess supply air. This option is not very commonly used. The supply fan type option determines whether to add an additional load to account for the heat generated by the fan and motor. For draw-through, CHVAC will add the fan and motor heat gain to the supply side of the coil. For blow-through, CHVAC will add the fan and motor heat gain to the return side of the coil. For package fan, CHVAC will not add a load for the fan and motor since that heat gain has already been accounted for in the capacity of the equipment. If you select either the draw-through or blow-through fan option, you will also need to enter the fan and motor efficiency and the static pressure across the fan. These inputs are used to determine the amount of heat gain that the fan and motor produce. Since our equipment will be a package unit whose capacity already accounts for the fan and motor heat gain, select Package Fan. The Occurrences input lets you turn the loads in this air handler on or off with 1 or 0. Enter 1 since we want this air handler's load to be included in the total building load. The Room Exhaust May Not Exceed Supply checkbox is for situations where you have a room in which you have entered more exhaust than the supply air requirement for the room. If you want the program to artificially increase the supply air for that room to equal the exhaust you have entered, check the box. We do not need that to happen for this project, so leave the box unchecked. The heating coil option to use a supply CFM makes it so the leaving heating coil temperature will be adjusted to work with whatever supply CFM you enter. It is more common to simply enter the heating coil temperature, so type 140 into the temperature box. Notice that the leaving heating coil temperature option was automatically selected as we typed 140 into the temperature input. For the cooling coil, the usual thing to do is enter the temperature instead of the relative humidity of the air leaving the cooling coil. So enter 55 for the temperature. If it turns out that a 55-degree leaving dry bulb temperature is impossible because of the psychrometrics of the system, CHVAC will raise this leaving coil temperature until it is psychrometrically possible. The psychrometric report and the psychrometric chart report will both show the final leaving coil temperature that is used by the calculations. If you already know the amount of supply CFM of your equipment, you may enter that value for the leaving cooling coil CFM here. The program will account for any amount higher than the minimum CFM needed to cool the space to the desired temperature by adding a supply-side load called reserve or reheat to the results, or it will adjust your leaving coil temperature, depending on which option you selected for excess supply air. If you enter an amount that is lower than the required minimum CFM, this value will be ignored. Click the General tab. The operating profiles inputs on this window lets you select different profiles to use than the ones you selected as the defaults for the project on the General Project Data window if needed, which we can see here were profiles 1, 2, and 3. In our other video about using defaults, we have already overridden the General Project Data window's 5% heating safety factor to be 10% for this air handler. Remember that these safety factors are only applied at the room level of calculations, not at the air handler or building level. The chilled and hot water temperature difference inputs are for systems for which you would like the program to calculate the required flow rate of water to meet the load. The steam energy input for steam systems lets you enter a BTUH per pound of steam so CHVAC can calculate the pounds of steam per hour, which will be shown on the psychrometric report. The optional percent sensible capacity input lets you specify the sensible to latent split of the capacity of the unit in order to determine what CHVAC calls the adjusted load and tonnage of the system. The adjusted load shows you the capacity needed in order for the unit to meet both the sensible and latent loads of the system. It's not commonly used for commercial systems. The cooling load method input only needs to be changed from net to adjusted if you want CHVAC to use your value in the percent sensible capacity input to determine the capacity needed to fully meet both the sensible and latent loads of the system. The people diversity factor is used to account for people moving around in the building. Although the maximum number of people should be entered for each room to ensure that there is enough supply air to include the people load, this number should be reduced somewhat at the air handler level in order to avoid oversizing. This value is normally 100% except in certain situations. Buildings with auditoriums typically need people diversity factors. You can leave this input at 0 to default to the default value entered on the General Project Data window, or enter a value greater than 0 to override the default. Note that the people diversity factor is applied at the air handler level, so that the load due to people for this air handler will be adjusted according to the percentage you enter here. If this air handler will be used only for heating or only for cooling, you can select the appropriate item here in the calculation options. If the setting for this air handler is the same as the option you selected on the General Project Data window, leave the default option selected. Click the Infill and Vent tab. The infiltration and ventilation options can be entered both here on the air handler data window and as overrides on the room data window. If you do override these at the room level, the program uses the value you enter at the room level as that room's contribution to the total ventilation or infiltration of the system. For example, suppose you had a project with 2 rooms and you entered 5 CFM per person here for the air handler. Then, on the room data window, you entered an override value of 10 CFM per person in room 1 of your 2 rooms, but left things at the default value of 5 CFM per person for room 2. The program would then use 10 CFM per person for room 1's contribution to the system's ventilation and 5 CFM per person for room 2's contribution to the system's ventilation. The total of the 2 rooms' contributions would then be used for the system. The total amount of ventilation air for the system would work out to be somewhere in between 5 and 10 CFM per person for the whole system. Ventilation is outside air that is brought into the system on the return side of the coil. If the outside air CFM is lower than the supply air, then some return air will be mixed with the outside air on the return side. Let's use the CFM per person option for heating ventilation, which is already selected. Click the drop-down Help button beside the Value input. Let's select the office space option, which is 5 CFM per person. For cooling, we will also use the default option of CFM per person, which is already selected. Click the button beside the Value input for cooling ventilation, and select the office space option here too. Infiltration is outside air that seeps into the conditioned space through the building envelope. Unlike ventilation, infiltration is a supply-side load that occurs in the rooms. You may enter both ventilation and infiltration, but in some commercial projects, entering infiltration is not needed since the positive pressure from ventilation is considered enough to prevent it. Click the Indoor Conditions tab. In the Indoor-Outdoor Design Conditions video, we have already overridden the indoor temperatures for a couple of the cooling months for this air handler to be different than those on the Indoor-Outdoor Design Conditions window. For more information about how these overrides and the overrides on the room data window work, see that other video. Click the Miscellaneous tab. There will be supply and return ductwork in unconditioned spaces feeding the rooms in this air handler, so let's enter some temperature change values to account for the loads due to ductwork. Click the drop-down Help button. Since the current input is for the supply ductwork in winter, the value in the Winter Drop Supply column will be selected once we click an item. Let's select the second row, which is the larger option for insulated ductwork. Now let's select the same option for each of the other inputs. Select the second row again. This time the value inserted will be 2.00, which comes from the Winter Drop Return column. Normally, when outside air is pre-treated, energy must be used to heat or cool the air. CHVAC will account for the pre-treated air load in the total building summary report unless you check the box labeled Ignore Pre-treated Load at the building level. Note that if you include the pre-treated load in the calculations, the sum of the ventilation load and the pre-treating load will exactly equal what the ventilation load would have been if the air had not been pre-treated, unless the building load happens to have a different peak time or month as that of the air handler, and then the sum may be a little different. If you are using pre-treated air, then in these inputs you need to enter the temperature to which the outside air is being raised or lowered before it reaches the air handler. These inputs let you specify whether a heat recovery ventilator will be used, and if so, what the sensible effectiveness ratio will be. A heat recovery ventilator in the winter reduces the outside air load by warming up the outside air by using a heat exchanger that extracts some of the heat from the air being exhausted from the building. In the summer, the exhaust is used to cool the outside air coming in. In order for the HRV inputs to have any effect, you must be sure to enter exhaust in one or more rooms in this air handler. There must be both ventilation and exhaust present. Ventilation can be entered either on the air handler data window or on the room data window, while exhaust can only be entered on the room data window. Note that it is not necessary to say that the air is pre-treated when specifying that HRV equipment is being used. The pre-treated air inputs are independent of the HRV inputs. Click the Duct Sizing tab. The duct sizing inputs here can be used to calculate the optimal sizes for the main trunk and for the runouts that feed the rooms. The equal friction sizing method is used. You may override these runouts inputs for any room in the system if needed. Click the Equipment tab. It's too early to enter anything for equipment since we don't know what the loads are for this air handler yet. So we can ignore all of these inputs for now. Also, remember that none of these equipment inputs affect any of the program's calculations. They are only provided so that you can include some information about the equipment on the reports if you'd like to. Thanks for watching.